tetradentate ligands. Now what happens in case of tetradentate ligands? We have triene. Triene is triethylene tetraamine. Triethylene tetramine. So we have NH2, CH2, CH2, NH, CH2, tetraethylene means 3 CH2 groups. CH2, NH, again CH2, CH2, NH. Right, we have 3 ethylene groups present. 1, 2, 3 and 4 lone pair of atoms, right? 4 lone pair of atoms means density is 4. That is why we call it tetradentate ligand. Next we have EDT, that is last we have hexadentate ligand. Hexadentate ligand means where the denticity is 6. Right? Example is EDT. What happens here? Just like this, CH2, CH2N and NH2. Instead of NH2, we have 4 acetate groups. What are acetate? CH3, COO, O minus, CH3, COO, O minus, CH3, COO, C double bond O minus, and we have CH3, C double bond O minus. Hexadentate, yes, 4 oxygen groups and 2 nitrogen groups. If somebody asks you the charge, what is the charge on EDTA? It's -4. Remember the charge. Yes, this is your EDTA. This is the last classification on the basis of denticity of ligands. Now we have the next topic that you have to study is chelating ligands. I have to rewrite it again. What are chelating ligands? What are chelating ligands? Some multi-dentate ligand ligands form bond with central metal atom. Some multidentate ligand, they form bond with central metal atom and form ring-like structures. Ring-like structures called chelates. chelates. And ligands, such ligands are called as chelating ligands. Next we have, I'll show you with the help of example the chelating ligands and what are chelates. Suppose we have nickel NiNH3 whole twice versus nickel En whole twice, that is ethylene diamine. Now this compound, it will be written as CH2 NH2 CH2 NH2 metal. Yes, metal, or you can say simply write nickel. Ni2 plus. So can you see ring-like structures, formation of chelates, or you can say chelation. Can you see chelation? There is formation of 5-member rings. Yes, 2 5-member rings are formed, or you can say chelation. So therefore, this compound, we can simply say that NiEn whole twice, it's more stable than NiNH3 whole twice due to chelation, or you can say due to the formation of rings. This compound is more stable. So that is why it's important to study chelation. Next we have, so the complexes of chelating ligands, they are more stable than the simple complexes of simple ligands. Now let's try to discuss about the stability of rings. What about the stability of rings? Stability of rings. Now what happens for the stability of rings? What happens? Suppose we have a 3-member ring, then we have a 4-member ring, then we have a 5-member ring, a 6-member ring. So this is the stability. The angle is 120 degree. Here it's 108 degree. Here is it's 90 degree. And here the angle is 60 degree. So as the angle increases, the ring size also increases, and thus the stability also increases. So therefore, the ligands with 3 or 4-member rings, they do not undergo chelation. The ligands with 3 or 4-membered rings, the ligands with 3 or 4-membered rings do not undergo chelation. Right?